the dark.
Yeah, exactly. Right. Just going to wait a little bit for attendees to join us. See, they're starting to file in.
Sounds good. Got some familiar names coming on there.
Yeah, it's always great to see them comment in the chat or put a question in the Q&A.
Absolutely. And we definitely want chat comments today, folks.
Yeah, that's right. You've got quite a few poll questions, so there's going to be a fair amount of interaction. Okay, so before we get going, we'll just answer a couple of poll questions here. So thank you so much for those who have responded. It looks like we've got representation once again from coast to coast. And let's just show you here, mainly from Ontario, but from British Columbia all the way through the Atlantic provinces, and then a visitor from the United States. And let's move to our next question, which is, what occupation are you in? We'd like to know who we are speaking to today. So
it also helps us to know who we can make fun of and who we can't.
That's true. That's
yeah.
true. Yeah.
A little humor goes a long way when you're trying to talk about something so technical.
Exactly.
That's a nice mix. Look at that, eh?
Yeah, really. Oh, look at that. And let's see here. So yeah, if you're, that is a nice mix. It looks like we've got representation from every single category. So that's excellent. Nice to see we've got builders and renovators and the construction trades in here. EAs, anybody, if your industry is not mentioned, just let us know in the chat. So here, I'll go ahead and share that. So it looks like predominantly builders, developers, renovators, construction trades with some EAs and some utilities and manufacturers and whatnot. Thank you so much. Thank you so much for participating in our first of several polls today. So my name is Stephanie Coleman and I'm with Building Knowledge. And today we have Andy Oding, who is going to be speaking to us about basements and making sure that these spaces are comfortable and cozy for all of us. Just a quick little bit of Zoom housekeeping before Andy takes over. The session is being recorded and I'll be sending out a resource email afterward with the slides and links and that sort of thing. So so look for that hopefully by the end of day tomorrow. That will all be ready. Any questions that you have for Andy, please just include those in the Q&A function. And then as Andy's presenting, I will interject every now and again with your questions. If you have some general comments or any sort of trouble, just post that in the chat and I'll be happy to give you a hand with that. And at the end of the session, we'll ask you to complete a survey and so that we can continue on the path of continual improvement. So of course we want to thank Enbridge, who is the sponsor, for supporting us in this. And you know, it is they're such an incredible sponsor to the building industry, and so we want to thank them for that. So I will stop sharing my screen, Andy, and I will hand the floor over to you.
Alrighty, thank you, Stephanie. Let me know if I actually get my PowerPoint presentation set up correctly here this morning. So yes, so here we go, folks. Welcome. I was saying to Stephanie, we almost should maybe rename this session the Dark Art of Basement Construction. It is fascinating, isn't it? We live in areas, many of us, where basements or crawl spaces are normal. But I'll just remind all of you that you are in the minority. The majority of homes in North America are in fact built in slab on grade situations. Sort of fascinating, isn't it? And like you've heard it talked about before, Why do we have basements? Well, it started because in cold climates, we needed to get the structural foundation of our homes, the footing, down to below the frost line. And when we would dig those trenches with hand shovels and we would get those footings or rubble foundations down there, it was just probably just as easier to dig hole instead of a big trench and just leave it unfilled. And so we started out with these cold cellars in the basement, we would call them. And many of the old basements would fill up in the spring. How many of you have been in homes that were built, 100, 115 years ago, where the basement actually had separate trenches in it that every spring, as the water tables would rise, you would see a little water in the basement and then it would disappear. That's what basements are. So today we're going to talk a little bit about some of the best practices behind basements. And my take on this is, from my experience from years as a building homes with a lot of good trades and contractors working with homeowners, is basements are very inexpensive living spaces. And yet you have to think about basement construction very differently than you do from above grade. So a couple things in the agenda today. We're going to hit on number one. We got to talk about what it's like down there. Conditions below grade are different than above grade. Very, very different. Number two, the design priorities. First things first. It's like anything else with building science. Sometimes we get so taken up, for instance, with vapor barriers that we forget the importance of air barriers or water resistant barriers, which are far more impactful than vapor control. Three, we're going to talk about some design product solutions, just some things that we see, some technologies that are helping with making better livable basements, and then some mechanical foundational things for basements, because as much as we can take care of the passive elements of the basement, we also have to have some active elements in the basement. We cannot leave that alone. So some of these are from our experience building basements. Some of this is from our experience, quite frankly, from tearing basements apart to fix them after things went wrong. And there are situations at some point I feel like I would like to write a storybook about basement issues because there are so many cool building science issues that come to play in building below grade. Real quick, give us your experience. What percentage of homes or projects that you're involved with, do you actually have fully finished basements? This is, and the reason we ask this is we are seeing typically an upswing in the amount of finished basement space these days. Isn't that interesting? 75, 30 to 50, and 75% or more. Wow. Yeah, thanks for that, Stephanie. So a large number of basements are being filled. I was having a conversation earlier this year with one of our clients. They build outside of the Greater Toronto area over in the Seton area, and they build multifamily and single detached. And they were saying, you know what, Andy, we're going in, we're going to offer basements because not only are we being asked for them, people have home offices, they're spending more time at home, but to be quite frank, finished basements come with a very nice margin, and it's easier for the original constructor of the home to do it. There's also things that we can do as builders with that new home that the homeowner can't do afterwards as well. So things are definitely changing. Question number two for you. Just notionally, since 2018 to 2019, since the onset of COVID, are you finding that people are asking for more finished basements? Just notionally, what are you hearing? So again, just throw your thoughts in there. This is more just some qualitative anecdotal feedback. back in, this was back in 2000, probably 2008, we had a little community. I was working for a large home builder, really good group in the Kitchener area. We had about 160 single detached homes we were doing, and about 27% of the basements were finished as an option. And it was great. We loved them. They were Energy Star homes. But we also had known that finished basements in new homes can be a real trick because they do come with issues. And sometimes builders, including ourselves, would prefer not to finish new home basements because the concrete is still drying out and there's nuances with below grade construction. But we had decided to go ahead and do it. And I and the team with the builder I was working with, we actually called our good friend John Straub, Dr. Straub, University of Waterloo, RDH Building Science Labs, and said, John, if you're going to build a good basement in a new home, what would you do? And so I'll just tell you today, some of the things I'm going to share with you actually were things that John shared with us. And he said, you know, it's really simple. You control the water, you warm the surfaces, you drain the rain, control the air leakage, and do a little dehumidification. And out of that, we ended up actually marketing our high performance basements. And we saw the purchase of new home basements go up, and we actually raised our prices a little bit because we could provide a better basement. Good, thanks for that. Excellent. So yeah, we are seeing a lot more requests for finished basements in new homes. You know, the warranty programs, Tarion, the Alberta Home Warranty Program, the Atlanta Home Warranty Program, BC Housing, it's very consistent across Canada. We are seeing still consistently some of the most I would say most money, most issues with home warranty programs have to do with below grade construction. We still have issues with liquid water. We still have settlement cracks. We have some structural problems, but the ones in red specifically speak to things that are not necessarily structural, but have to do with water in all different forms, whether it's liquid water, whether it's water vapor, whether it's capillary action of water. And again, occupant discomfort with cold floors and dampness. So down in the basement, a couple of things to keep in mind. The ground is a heat sink. So the ground is cold. Back in the 1970s as a kid, you know, I remember being in houses that were earth berm houses, and we thought we were going to build houses in the ground and we were going to insulate them with earth. And those homes, if any of you have ever been in them, there's just a couple things that come to our mind is that they smelled bad and they were uncomfortable. And we learned very quickly that, sorry, even in a cold climate, the ground is cold and it is wet and it is a heat sink year round. So we came back out of the ground. The other thing too to keep in mind is that the predominant heat loss from a below grade structure is at the edge. So these little things like thermal breaks at the edge of the basement slab are still incredibly important to get those little pieces in there. The other thing too is that heat loss or the cooling of the basement slab and wall can be affected by the depth of the foundation. Let's keep in mind that you only need to go 1.5 meters below grade to get your typical ground temperatures. And then if you have fluctuating water tables as well, water is highly conductive and it can pull the heat away from a slab. I had this situation back in 2006 in a home, a subdivision of over 250 homes. We had one house that there was condensation occurring on the top of the slab, one home. And when we did some testing in the soils with piezometers, what we found was that there was active water flow through much of the soil below, not visible by the eye, but water flow through the soil. And it was a perched aquifer. So just in that area of the site, the water table was slightly higher. Now that water was moving through the soils at a pace that was drawing heat from the slab, thus cooling the slab exponentially, causing condensation to occur on the top of the basement slab. And we had tried everything. We actually ended up moving the folks out. We cracked the slab out. We put under slab insulation. We put the slab back in and we finished the basement, and that took care of it. But again, there are going to be some what we call outliers or border situations where the presence of water is going to affect. The other thing to keep in mind, and this ties into your homeowners, is that the coldest temperature in the basement, the coldest temperature that the wall or the floor will be, will actually happen 4 to 5 to 6 months after the coldest outdoor temperature. There's what's called a seasonal lag. So when we get those really cold temperatures in February, it seems like now our coldest days tend to be in that February range. And depending on frost levels, depending on snow cover as well too. Sometimes if you have a season without a whole lot of snow, the ground temperature will actually drop a bit more because it's more exposed. But anyways, you have February as the coldest outdoor temperature. Now, if you take that 3 to 4 to 5 months after, that places us directly in late spring, early summer, that the basement is actually going to be the coldest. And this is this time of the season when, as builders and designers, we get these funny phone calls from homeowners saying, hey, I've got a leaky basement, when in fact we know it likely isn't liquid water, it's condensation. We're starting to see the reverse vapor drive start to come in contact with very cold materials in the basement, and it's condensing. The other third thing to understand that's different about below grade than above grade is that above grade in Canada, the majority of drying that our structures do is to the outside. But below grade, we dry to the inside. There is a little bit of winter vapor diffusion to the outside, but very, very little. And this is the interior drying is exacerbated by the fact that we also don't like to have a lot of exposed concrete in the ground these days, right? We're trying to get that ground and the finished grade all the way up so that people don't see the, up to that minimum, what is it, 4 to 5 inches of freeboard that was required below the cladding. So the majority of basement drying is to the interior. So that's something to keep in mind too, because that is different than what we have above grade. Now, when you are designing for below grade structures in new homes and existing, I would argue as well, here are your priorities. And this is a little bit in order of priority, but they're all important. The first one is liquid rain. Ground control. We're going to talk about these individually. The next one is soil dampness. We know that soil is always 100% RH. If it gets against the concrete, you will have moisture flow through the concrete by capillary action or by vapor diffusion to the inside. And this is why we have often done damp proofing in the past. Not only does it actually resist some of that vapor flow or moisture flow, but it also disengages the concrete structure from the ground so that the ground cannot adhere or frost freeze to the concrete. The next one is construction moisture. Our basements have a lot of moisture in the concrete. That's an issue. We also have air leakage, and this is a huge deal. And how does that affect basements? We also have to control the surface temperatures or we get condensation. And the last one is we have to condition the space. So these are sort of your principal points, and we'll talk about each one individually. Number one, drain the rain. Joe Steebrook, John Straub, Gord Cook. I could go on and on. Mike Leo, all these folks that have been such good building science mentors to all of us will say it again and again, drain the rain. And don't just drain the rain from the house roof. Get the water away from the foundation as fast as you can. We don't want water sitting up against it. And for those of you under construction, the other thing too is we have this propensity sometimes when we're building our homes that, oh, it's under construction, we're going to get some ponding next to the concrete. Hold on. It is worth making sure that during the construction of the home that your grading team gets in and keeps the water away from those freshly poured foundations. The sooner you can get liquid water away from those foundations, the sooner that foundation can commence its drying process. And you want that early in the construction process. Get rid of the ponding. Leak control, liquid water again. So this liquid water, if we have it up against the house, how does it get in? And this is an important equation to understand. And it's one that has seemingly been solved through air gap drainage products. But let's talk about this. A leak comes about primarily because of three things. And in order to have water through a hole or to get air through a hole, you have to have three items to the equation. You have to have a hole, you have to have a pressure difference, and you have to have a liquid or a substance. If you get rid of any one of these three things, the leak disappears. It stops. Now, below grade, we're never going to get rid of all the holes. Face it, unless you feel like you can build the perfect below grade structure and the trades are going to have a perfect day and no one's ever going to do work as if it's Friday at 4:30 and needs to go home, you will always have small holes. And this is one of the reasons why Ontario back in 2000, what was it, 2010, said no to requiring waterproofing of foundations and said yes to air gap drainage membranes. They realized through good building science that it wasn't about getting rid of the holes, it was about getting rid of the pressure differences. We know there's always going to be some water at some point in time, but get rid of the pressure difference. And that's what this air gap drainage membrane actually does. In the below grade, you'll see here that even if water does get past the system platen and it's between the system platen and the wall, it still drains. The reason it does not continue to go through the hole is because the pressure between the backside of the air gap drainage membrane and the basement has been neutralized. So when there's no force to push through the hole, you're okay. And that's why air gap drainage membrane is this beautiful, better, more eloquent solution to managing water than is even waterproofing. The other part is capillary action. And obviously this is something here that we don't see very often. We do see it in areas where there has been a history of placing the footings in direct contact with very silty soil or clay-like soils, because the footings will suck the water up by capillary action, which literally is simply water by surface tension working its way through the holes, pulling itself through the pores, because the pores in concrete are the perfect size to be a sponge. It pulls itself up into the wall and then it moves into the home. It diffuses into the home. So to stop that action, there's a number of products that you can put on top of the footing to stop that action. Sometimes in some areas, they'll actually put a layer of crushed, compacted, engineered stone under the footing, and that can provide a capillary break as well too, just like the clean, clear stone does underneath the slab. Soil dampness. The other thing too to keep in mind is there is a lot of water in the ground. It's 100% RH. The other note is that our concrete that we build with has thousands of gallons of what's called unbound construction water. This is the water that is used for the placement and the formation and the curing of concrete, but the unbound water in that concrete is going to dry out as the curing takes place. I think I read somewhere a year or two ago that the Hoover Dam that was built in the Southwest US only has commenced its final curing process in the last 10 to 20 years. So that's how long it takes some structures to dry out. Now, some of that is related to the out into exterior conditions. So we used to think that, concrete basement walls will dry within 2 to 3 years and then it's done. Folks, it's longer than that. For the most part, you're likely looking at 5 to 7 years for that concrete slab and wall to really finish its drying or to get into the last stages. During that time, it's about managing that extra water that's going to be drying to the inside of the home. The other thing too with this soil dampness is this thing called reverse vapor drive. Because the wall tends to dry to the inside, we end up with water sometimes showing up on the backside of the vapor barriers in the basement. I'm not going to get into this topic today, only to say that our building codes in Canada still have a long way to go when it comes to requiring full stop vapor barriers below grade. For some reason, some of our friends to the south of the border have been able to figure this out. You have the folks over in the state of Minnesota who build in very similar climates as we do here in Canada that simply said 4 to 5 years ago, stop with the vapor barriers below grade. It's causing issues for finished basements. They don't belong there. It's on the wrong side of the wall. Do something different. Here in Canada, we're still trying to figure this out. I know that there's code committees trying to work on this, but we continue to see this issue below grade because the building codes are still nuanced and they're not very clear. So how do we deal with this reverse vapor drive? Well, there's really only a couple things you can do. You can stop the vapor drive that comes from the wall back into the home, or you can throttle it back. So slow it down, sort of like putting a brake on it, so that as it does move through, it moves through so slow that it doesn't actually condense. The other thing you can do is just let it through. Stop using full stop vapor barriers such as poly and start using things like smart vapor retarders. And we'll talk about what that means in just a bit. The other part that we have to address is air leakage. Air leakage. Remember the building science of air leakage. When we have air going out the top of our homes, and we still do, in particular attics, through pot lights and other things, warm air, or the warmer air, by buoyancy goes out the top. Building science says air out equals air in. So when the air goes out the top of the home, air comes in the bottom of the home, below the neutral pressure plane. So the argument can be made, houses that have a very poor lid have very cold basements. And it's true. The best way to create a drafty basement is by having a very poor air barrier up top of the house. Now, you also need to make sure that the air barrier is complete through the basement. Again, a leaky house equals a cold, drafty basement. The other thing too is a leaky house also equals a humid basement, and a basement that will have soil gas concerns. So as much as there is this concern on social media and by others about these tight homes that are bad for soil gas and radon, the fact of the matter is, one of the best things you can do to mitigate and reduce soil gas ingress is actually a good tight air barrier first. And then second, then do sub-slab depressurization after that. So again, a tight home helps with a number of things. The other thing that we have to talk about is cold surface condensation. And this is one that is very nuanced, but it's one that we have to understand. Remember what we said, basements are cold, and they're cold when it's warm and humid outside. And it's those late spring, early summer months. And what happens is, this is typically the cause of that good old basement smell. You know, sometimes we'll ask, folks that are designing their new homes to efficiency or deep energy or for healthy purposes, we'll ask them to comment on, what have former homes felt like? What are some of the places that you've lived or existed or visited where you didn't feel healthy or you didn't feel right? And then where are some of the places you lived that felt comfortable and warm? And inevitably we get this comment that, yeah, I did have a basement in a house and it smelled funny and it was dark and it always felt damp. Well, guess what? This is part of the problem here. So one of the things we have to do is we have to start thinking about what is this surface condensation, and why is it that in basements it's going to be so important for us to make sure that relative humidity does not exceed that 60%. And one of the reasons is because when you do go above 60% relative humidity, you now may have condensation or water forming inside the pores of concrete, cold surfaces, wood, cold surfaces, cardboard box, cold surfaces, IKEA manufactured desks and bed tables and furnishings on cold surfaces. And what this has to do with what's notionally called the fourth phase of water. Remember, we have water as a vapor, we have water as a liquid, and we have water as a solid as ice. But this is notionally called the fourth phase of water. And what happens is, when you have porous building materials or porous surfaces, when you have RH that is low in the home, you might have maybe one layer of water molecules on the surface of that material, and it's not a big deal. But as the RH continues to go up, you start to get another layer of water molecules added to another on top of it. And what happens is, once you get 7 to 8 layers of water molecules, you will start to then visibly see condensation. So invisibly, there's always just a little bit there. The problem is that's not a problem here at 60% if it's a glass or a metal. However, if it's a porous building material like wood or concrete or paper or drywall or trim or furnishings, even when it's at 60% RH, inside the pores, it will be 100. And that's the problem. So something that RDH Building Science has shared for several years now is this idea of being very, very cautious about this 60 to 80% relative humidity. We often think we only need to be concerned when it's 100. Baloney. In the basement and anywhere else in the home, we need to be concerned when we hit that 60% because we will get poor condensation in those materials. Here's what I want to remind you. The same air that's at 60% relative humidity in the basement on cold surfaces may only be a relative humidity of 40 to 45 upstairs on the main floor. So even though your thermostat, your nice Ecobee or Nest thermostat's telling you you should be happy, it's, air conditioning's running and it's 24 degrees C and I have a RH of about 35 to 45, which is really low for the summer, let's say 45, you should be happy. What you really need to be concerned about though is what happens to that air when it's in the basement against a cold surface. So these are things to really think about because this does affect basements. I'm going to ask a question. So Stephanie, let's run this poll. From your standpoint, having knowing the design priorities, what's been your biggest challenge? Which one of these areas, you can name all of them if you want, but which one of these areas have been the biggest challenge when it comes to lack of direction, lack of detailing, lack of understanding in basements? Yeah, liquid rain, still huge deal, isn't it? Sometimes it's hard to separate these, isn't it? As to water, no matter what it is we're talking about in some form. But yeah, that's good feedback. Look at that space conditioning right up there next to liquid water. How do we condition the space? Second, the third place is cool surfaces. Yeah, we just don't hear a lot about this, do we? I know we've all seen eyes of builder. We go into houses and we look at the relative humidity upstairs and it looked perfect. And yet the homeowner is down in the basement and they've got mold growing on cardboard boxes and all sorts of things. What's going on? Why is this happening? Good. Thanks, Stephanie, very much. So let's talk about some of the solutions. Now, we know from the building science perspective here in Canada, for years, even from back in the 1980s, 1970s, 1980s, you can read some of the original Building Science Digest work done by the NRC and good building science folks, Ted Kessick, Ted, there was Neil Hutchin, Gus Handegord, who wrote The Cold Climate, John Timisk, so many of these folks that did studies on below grade insulation, and they all came to the same conclusion. It's better to do it on the outside. So often in building science, there's what we call the good, better, best. All of them are better than code. Code is what we do so we don't go to, I'll just say it, jail. It's not what we build to guarantee comfort, health, and resiliency. But good, better, best in building science, the best from a basement solution is in fact to insulate from the outside. You limit thermal bridging. Some materials, some insulation materials can in fact act as both a hydrostatic or an air gap drainage membrane control and as a drainage layer. Again, see the manufacturer's information. Some products can act as an air barrier out there. Some of these products can actually have a permeance that it acts as a vapor throttle, so you don't get the amount of high vapor diffusion moving through the wall, driven both by high RH of the soil and by sun-driven moisture. The other thing too that exterior insulation does is it limits the freeze-thaw cycling inside the concrete. So the concrete doesn't see that continuous expansion and contraction within the pore structures. Year after year, sun comes out, sun goes away, freezes up, thaws again. And what happens is the concrete is actually retains its durability much longer. The other thing too that this does is it keeps that concrete warm so that the first condensing dew point for the interior air is warmer. So the RH can be held at healthy levels in the basement without coming in contact with a cold surface. The other thing too is some insulation materials, again, check with the manufacturers, are now certified also as a radon barrier system. Just a little note, always remember that little edge of slab is so very critical in basements. If you can't do best practice, better is still phenomenal. So if you can't get the insulation on the outside for a lot of reasons, you're afraid of the hockey pucks here in Canada hitting it, you can't find anything to cover it, maybe you have issue with side yard setbacks, 0 lot line tolerances, so you can't encroach into the side yard. I know that some of the foundations I've poured in my day are so close to the side yards, you actually have to pin the footings for your foundation guys because you are so close. So you can't give up another inch or 2 into the side yard without a zoning approval. In those cases, you can put some of that same insulation type material on the inside. Again, look at the manufacturer's instructions. Again, you have the thermal bridging control. It can also act as an air barrier, again, based on the manufacturer's certifications. It can act as a vapor throttle, believe it or not. Low perm insulation on the inside of a foundation can start to significantly reduce the amount of condensation we see on poly or other surfaces inside the condensation wall. It also warms the first condensing dew point, and it also can, again, based on manufacturer certification, can be part of the radon barrier. So again, if you can't do it outside, maybe you can do it on the inside. So the other thing too is there are some alternatives to using poly, again, as an air barrier and a vapor barrier component. These low perm foams, whether it is a spray applied, whether it is a board applied, these low permiance foams can act both as air barriers and vapor barriers when used based on manufacturer's instructions, and you can start to get rid of the poly below grade in that instance. Here's a nice example of what we would call a building science synergy. It could be pink, it could be blue, it could be silver, I don't care. This happens to be a low perm rigid insulation. In this scenario, this material can act, again, if certified by CCMC or others, by the manufacturer, it can act as the insulation layer, it can act as the air barrier layer, it can act as the vapor control layer, and as a soil gas barrier. How does this low perm insulation on the inside result in limiting condensation? Well, here's a little study again, thanks to the folks at RDH, a little study that was done just showing, all these blue points here. These are areas where you're going to start to see condensation on the back of that poly. So here's just a typical roll bat of insulation with a poly facer. We see condensation starting here and moving for several months across the course of the year. We see the same scenario here. And again, in this scenario, we have a Roxel or a rock wool, a semi-rigid mineral wool that's put in. We have house wrap we put up against the basement wall because we sort of think that maybe that's going to help with vapor diffusion. And then we put poly, and lo and behold, we still get condensation. I've had this question. I tried this for years. Put house wrap up against the basement wall. It does provide a redundant drainage layer in case water gets past the system platen, as long as it's placed down under the slab, but it does nothing to control water vapor diffusion. The house wraps are permeable by nature, so sun-driven moisture, vapor diffusion from moist soils still will blow through like John Straub would say, like poop through a goose. It's vapor permeable. The key to the situations here is, number one, if you put in a low perm, in this case, it's just 1 inch of low perm insulation back there, suddenly you can see the difference. Limited potential for condensation. Now, if you want to do even better than this, what you would want to do is start to look at a smart vapor retarder. And that is, regardless of the type of insulation in the wall, the very best scenario is to start to use products. And again, this is just one of 4 or 5 products. Certainty just happens to have been on the market the longest. There's others that are made by other manufacturers. But what these are called by code are variable perm vapor control materials. And these typically materials are made as opposed to polyethylene, they're actually a nylon based. And what happens is when these materials start to see, let's say 45 to 50% relative humidity behind them in the wall, the cell structure will start to open up, just like sausage skin does, just like wood fiber does. And it lets that relative humidity or that water vapor then just move through into the basement, which is great, instead of condensing. And then when it's no longer there, it goes back to a closed position. We have seen these materials used notionally in basements where there has been condensation behind the poly. They take the smart vapor retarder and they just tape a piece in place, and the entire wall assembly then dries out. We have a builder in the Sudbury area. They build 50 to 60 homes a year. They were having tremendous issues with this. They had a lot of exposed concrete because of grading changes. And he said, you know what? We just simply put the smart membrane on the south and west facing walls. Isn't that interesting? Why? Well, because he said that's where we were seeing the condensation. Why? That's the primary direction of the sun hitting that wall, heating it up, and creating high vapor pressure to the interior. And this was the answer. It let the wall dry to the interior. Down here, again, is a little bit of a modeling and monitoring project that RDH did, showing, condensation here, these solid blue lines in a typical scenario with poly. But if you move here and simply put in a smart vapor retarder or a variable perm control material, all of a sudden you don't hit the condensing point because the moisture dries into the basement. So this is really an ideal solution. Let's talk about space conditioning, because we are finding that this is also one of the problems with basements. We often walk into basements these days. We get a call from, a homeowner, we get a call from a builder, we get a call from the warranty program saying, we've got a basement issue. And we go out and we go into the basement, and the first thing you notice is it feels like a meat locker. It's cold and it's humid. Something is going on. So one of the things you want to fundamentally start with, and to some of you, this will be, just the basics, but remember, you need to start with proper load calculations. If you are not doing CSA F280 load calculations for your home, there is no way in heck that your mechanical designer is going to be able to pick a right-sized air conditioner or air source heat pump. And if you don't pick a right-sized air conditioner and it is too big, I'm actually not worried about too small. I'm worried about too big. The air conditioner or the air source heat pump during the cooling season, which is going to start late spring, early summer, when the basement's the coldest on the materials, it will start up and it will short cycle. And the problem with short cycling during cooling is you will cool the air, but you will never run long enough to dehumidify the air. Typically, an air conditioner has to run for almost 8 minutes. A single stage typical air conditioner has to run for almost 8 minutes before you will see condensation on the coil. So again, the only way you can right size the condenser or the system is by having good calculations. Third, start to think about not just right sizing, but air conditioners that are multi-stage or at minimum 2-stage. These are units that have the ability to step back and to move the air at a slower speed, thus providing better dehumidification potential. The fourth thing, and this is a huge deal, is the sealing of supply side ductwork in the basement and returns. In Ontario and with Energy Star and the Net Zero program, it is a requirement to seal the supply side ductwork. However, we still are not sealing the returns. And what we find happens in that scenario is we run the risk of under air conditioning conditions. When it's running and your return is not sealed, we have seen scenarios in high performance homes where 80% of your return is coming out of the basement. It's not coming out of the grills upstairs. And that's because of unsealed returns. So folks, if you don't want a meat locker downstairs, seal the returns. Stephanie.
We had a number of questions come in, so
All
I
right.
thought I would take a moment to ask these. So, the very first question was, how much gravel do you put above the drain pipe? So this is a while back when you're talking about, I believe, weeping. So,
Yeah. That is a really good question for your geotechnical engineers. I'm just going to make a notional comment on that. Great question, a question that you need to ask. You want a good amount of good gravel, large stone around the pipe, platen, and even better than that, if you can, some silt cloth. There are two things that we have seen with basement water intrusions when that process is not done. One of it is because if you let the soil itself come in contact with the top of that drain pipe, it often can cause silting of your big O drain pipe very quickly. And what happens in that case is the water continues to move through the soil and it brings the silt out of the soil into the pipe, and it also starts to clog even the stone itself. The other thing too that I've seen happen, you got your stone slinger, he arrives on site, he backs up and he starts slinging stone. And I remember this happened, it's been 10 years ago or more, and he's slinging stone. And I noticed that the stone that was coming out the back had a lot of dirt in it. It had a lot of what we call fines. Went down and looked at the stone, and there was actually small stone, pebble size, and dirt that was included in that clean stone. Had them stop. And the reason is you do not want those fines in the clean stone. You need good clean stone that has voids between it so that you can facilitate drainage.
thank you, Andy. Another question. This is a multi-point question. So, what type of testing has been conducted on smart vapor control layers over time to see if variable permeance is retained over time, and what were the results and what was the time frame?
Great question. You know what? I don't know. That's a phenomenal question. Whoever asked that, what I would do is feel free to send Steph or I an email. What I'd like to do is maybe send that question to some of the manufacturers. We know them well. I think was it Sega, Certainty, some of them make these materials. Let's ask them that. My guess is they probably have some answer. These materials, again, we saw the membrane, for instance, started to be used over 12 to 15 years ago. So surely we have some data to date. But yeah, what does happen, right? You put it in place, it seems to work, the basement get finished, the drywall's there. What happens after that? So yeah, send us that question. Let's see what we can find out.
Okay, a third question was, can you suggest programs for designers and builders to calculate proper load calculations that are CSA F280 compliant?
Absolutely. Awesome question. So we're very fortunate in Canada. There is an association called HRAI. You can go on their website. HRAI is I'm going to say the membership of the mechanical associations, manufacturers, and so on. But more importantly, HRAI has a design credentialing course. Many of our team members, including myself, go through it every few years. And they have courses that provide credentialing and instruction on performing the CSA F280 methodology of heat loss, heat gain calculation. So HRAI does that across all the provinces. For those of you that are in BC and out west, TECA is another one. So TECA, and again, my apologies, the acronym's not coming to me, but TECA is the mechanical association. They've been for years in the BC area. They also provide courses and credentialing for that. And as far as softwares that you can use, so as opposed to doing it by hand and follow, the course, because there are embedded spreadsheets in the F280, there's our HVAC software online that can do CSA F280 calcs. And there is also RightSoft, which is another program that has a module that does CSA F280 12 calcs as well. Excellent. Are we good to go, Steph, with questions?
There were a couple that came up in the chat as well, if you have some time.
Yeah.
So let's see here. Does the foundation not do the majority of its drying in the first year or two? I heard 90% during that time frame.
That's sort of what we used to think as well too. But what we are being told through some of the studies that some of, I'm going to say, firms like RDH and others are doing, and what we're actually seeing happen in the field, is it's taking a lot longer. And where this comes from is the fact that it depends on the conditions on both sides of the structure. It depends, number one, how dry was that foundation when you first capped it and enclosed it. It also depends on how much freeboard area does the exposed portion of the concrete have around the home to provide some drying potential to the outside, that little bit of drying potential to the outside air, right, when it's cold and dry. So a lot of it depends, but the vast majority, what we're seeing is it takes longer than what we thought. And we're suggesting that you probably need to be looking at 1 to 5 years, if not longer in some cases. Now, how do you mitigate that? Keep the wall dry right from foundation. Get the water away from it during construction. Get some active dehumidification, commercial dehumidifiers in that basement. Believe it or not, folks, as well, when the house is under construction, after you're able to and you feel safe enough to, get the HRV or ERV running, get some ventilation happening in that home to expedite that drying, and put the insulation in if you can. If it's just going to be bat and bag, what we call the diaper, the insulation and the poly, if you're going to be using that, don't put it in till the very last. Give the wall time to continue to dry to the home.
One last question. So sorry, my audio wasn't working very well. Hopefully this is a bit better. So when you use pink, blue, or silver interior insulation as an air, vapor, and thermal barrier,
yes,
what specific detailing at the top and bottom are crucial?
Good question. Let's go back to this one. So I'm going to use pink. Again, we're talking about here just up on the top. So some of the rigid. Some of the detailing that's crucial is, number one, is to understand that it is an exposed foam plastic. So you are going to have to cover it with what is called a Class B thermal barrier. So notionally, that's been drywall. So that's why when we do exposed foam plastics, pink, blue, silver, doesn't matter, or spray, applied, closed cell, whatever, they make us put drywall on, is because it needs a thermal barrier. What does a thermal barrier mean? It means that the foam plastic, when there is a flame, will melt. And when it melts, not necessarily flammable, but it gives off a gas that is highly combustible. So that's why we need the Class B thermal barrier. Now, there is the ability to protect those exposed foam plastics with another type of Class B thermal barrier, and that is mineral wool type insulations like rock wool or thermofiber. So you can, again, based on the manufacturer's instructions, use that type of material that can provide a Class B. Now, the other point, and I don't know if I can zoom in on this close enough. This was a really good question you brought up. When you use a rigid board stock on the wall, it is very important, and you're using it as a rigid insulation. Make sure that you are doing a small bead of acoustical sealant or something along the basement wall so that you seal the top of the gap between the insulation and the concrete. Now, you can either do that with a bead of acoustical sealant and then just throw some fasteners in there, or you can use some appropriate construction type tapes or things to run across the top of the insulation onto the concrete or onto the sill to do this, or you could do a single lift of spray foam to seal that. But the reason that it's important, and thanks for that question, to seal this space is because you will always have a little bit of airspace and pocket between the rigid board stock and the wall. And you will have some water vapor movement that's going to be moving up and through the scenario to the top. So you will have some air leakage if you don't seal it. You could be exposing your plates and the rim joist assembly to higher exposure to water vapors. You could be letting soil gases in at the top. So again, make sure that you do seal that top. And again, when you are using rigid board stock, use the manufacturer's approved taping to seal the joints as well so that it's continuous. Hopefully that helps, but that's a really good question. Excellent. Okay, let's move ahead. So space conditioning, we talked about space conditioning. There was a couple other points I just wanted to make there. Again, we talked about the returns in the basement. Start to think, if you are doing a finished basement, spend the extra, I don't know, 75 to 150 bucks, take some tin tape, it doesn't matter, get in there and have them seal the returns, so that when you are trying to pull or allow, not pulling, when you are allowing air to come back to the furnace or to the air handler, that you're making sure that it's not all coming from the basement. You would be surprised how much of the return under air conditioning loads comes from the basement through unsealed returns. The ERV in lieu of an HRV is another one you are going to want to consider. Because the issues with most basement moisture happens in that spring, early summer, and through the summer. Just having an HRV in the home isn't going to be enough, because it's during those times that actually an HRV, when it brings air in, which you need ventilation. Doesn't matter if it's humid or not, you need fresh air. When it brings that air in, it's going to be hotter and wetter. And it's the worst time to put that hotter and wetter air into your basement or onto your air conditioning coil. So switching out for an ERV, what will happen with the ERV is it will pre-dehumidify that hot, wet outside air so that when it comes in for you to breathe fresh air, it comes in a little bit drier and a little bit cooler. And that does result a little bit in helping basements. Now, there is one more thing, and we have to talk about this. Every below grade space in North America is going to need auxiliary dehumidification. And what I mean by this is, in addition to all the other things we've talked about, warming the first condensing surfaces, right? Getting continuous insulation on the walls, on the other side of the walls, under your slabs, in addition to air tightness, in addition to right sizing, all these things, you also are going to then have you need the ability to take care of that additional moisture load. It's primarily driven by the release of the unbound water during the curing process. What we often recommend, and we did this for years as a builder, is every below grade area, including crawl spaces, needs auxiliary dehumidification. We're talking about a little space dehumidifier, not too big, and in place, tied to a hose that goes to the drain. It's going to be very important for the first few years in the home. Give it as a gift to the homeowner if you want to. If you gift it to them, it means that the warranty is their responsibility, because inevitably some of these little units are going to run out, but it's cheap insurance against the basement not being able to manage the amount of unbound water that will be drying to the inside. How much does it cost to run a dehumidifier? About $75 to $150 a year, depending on the size of the unit. Get a little Energy Star rating unit and simply set it at 50 to 55 RH in the basement and let it run. Again, that dry basement also means it's a better smelling basement. Now, there are going to be some scenarios in existing homes or in homes where you haven't done a good job with providing vapor diffusion control, where we haven't done a good job with having good capillary breaks, in homes where they're existing, so we have dampness that we can't get rid of. In those scenarios, you're going to need a dehumidifier in perpetuity with the home. It's really the only way to do it. So do some of the other things we've talked about already, limit the ongoing requirement for a dehumidifier, but in the new homes, you're going to need them for the first few years in particular. So sort of a review of what we've talked about. If you're going to build below grade and finished basements, accept the fact that the ground is cold and it's wet. There's no such thing as dry, warm ground in Canada. Get over it. So, number one, drain everything. Number two, if you haven't got to air gap drainage membranes, in Ontario, it's been building code for years, but in other places in Canada, not so much, get to it. There's still spaces in the US where they're still trying, should we do this, should we not? The jury's been out and the results are in. In Ontario alone, since having air gap drainage membrane, we have heard that there has been around a reduction of liquid water ingress below grade up to 80% in some cases. So it's a building science that works. Make it airtight. Another reason to get it airtight, stop the cold drafty basement, stop that soil gas from coming in, a good air barrier. Control that reverse drive of the vapor diffusion. And remember, two options, either throttle it back or let it through. Warm your condensing surfaces, raise the temperature of the concrete, raise the temperature of the concrete on the walls and the floors so that the furniture, the flooring, I don't care what it is, can be warmer so you don't get condensation in the pores and basements start to smell like basements traditionally do. And again, humidity control, design your mechanical systems to condition the basement in particular. And then the last thing on the humidity control is, aside from the whole house mechanical system, make sure that you have some small auxiliary dehumidification in that basement area. We do want to ask here before we take some questions in the chat or in the comments, because we like to take things and we use them to share with some of the committees that we're on, whether it's building code committees or whether it's program design committees or other stakeholders. Give us an idea of what recommendations you would make for stakeholders like building code development committees, manufacturers of products, trade contractors, designers. What comments or recommendations or asks would you have for the future of basement construction and below grade construction detailing? We've thrown some samples in there. Would best practices be a help? A scope of work specifically for below grade living spaces, would that be of interest? Changes to the current building code, absolutely. Others, and put them in chat, just let us know. So take a minute and just give us your feedback on that.
While people are filling in those comments in the chat, we did have a couple of extra questions come in. So
yeah,
let's just see here. The recommendation for finishes for exterior foam on foundations, can we do it without having to cover it with, say, PT plywood?
Exterior insulation on the outside of the foundation. Yes, there are ways to cover that. So the first option to cover exposed insulation on the outside of the foundation, the first option is to number one, talk to the insulation manufacturer. I happen to know that both Dow and Owens Corning do have relationships with material manufacturers who make a liquid applied like material coating that can go on their products outside that has high impact resistance. So talk to the insulation manufacturers. Second to that, talk to one of the good responsible stucco manufacturers. So let's say Drive It, Stowe, Durock. They also make coating materials that can be applied to insulations like this, along with mesh that can provide high impact resistance for those scenarios and can go down to grade. So that's the second one. The third one is send me an email or staff, because there are some products that we have seen start to come on the market primarily because of the shift in some of the US northern states, Minnesota in particular, where product manufacturers are actually making pre-made, and some of them are plastic molds that go over the top and down below grade. And they provide a nice, a good looking coverage and an easy to install material above grade.
Okay, thank you. One person had asked, what is the best way to improve the air in an existing finished basement?
Oh boy. So that's a big question, but what we would suggest and the way we approach that is by doing some building science forensics. Number one is you want to take a look at what are the conditions there. What's the, average temperature? What's the average relative humidity in the basement? So you can do a little bit of data logging or just some checking, a little $6 to $10 hygrometer and thermostat will be enough from down at Home Hardware, and just see what the levels are in that basement. And that'll give you a sense of where you are with humidity. The other thing too is to start to look at the condition of the ductwork, the placement of the diffusers in the basement, because you're going to want to reconsider some of that design from the return and the supply side. And the third thing is you're going to want to do a little behind the scenes investigation to see if there's any signs of wetting in the basement, on the slab or the wall, any signs of what's called efflorescence. And that is the salts that are left behind when you do have water that's been coming through in vapor form. And as it dries out of the concrete into the basement, if the water is coming from the soil, what will happen is it will leave the phosphates and the salts behind on the surface, and you'll see like a salty layer. Sometimes you see that on the out, and that's a sign that there are some issues with capillary action. So those are things. And then the other thing too is do an outside inspection. Look at drainage, look to see if they're ponding, look to make sure that you have adequate slope away from the foundation. Make sure that window wells are filled with stone, not a bunch of dirt as well. If there's weepers that you can get to, throw a hose in them and make sure they drain. Worst case scenario, get someone in to do a test on them. Those are some of the things you want to look at to start to notionally address how to make an existing finished basement better. Then after that, then start to look at things like, changing materials, maybe getting air purifiers, all that kind of thing. I would say immediately, if you don't get a dehumidifier in the basement, it's cheap first actions, get that going. Hopefully that's helpful. We do have, thinking of that, Stephanie, we actually do have an old checklist from 15 to 17 years ago. Gord Cook, our president, Gord, and a number of others, Gail Lawler and Tex, developed a program for Canadian Mortgage and Housing Corporation called Clear the Air. And there was actually a checklist for doing indoor air quality investigations for below grade. So you could go through, do a checklist to see the conditions of certain things, and then it helps you make decisions. So if you're interested in that, we could certainly share that with you because we still have that content.
Actually, if you zip it over to me, I could add it to the resource email.
Sounds good. I will go hunting for that. I know we have it. So.
Perfect. So a couple of more questions had come in on the Q&A, and then we had some responses to your question there.
Excellent.
So one person had asked, they mentioned that they're not a builder, so they wanted you to explain how waterproofing was done in the past in Ontario.
Okay. So historically, what was done in the past was you would see, and this was back pre, I'm going to say 2008, 2010, someone can correct me there. But in Ontario in particular, what was required at that time was that the foundation, or areas where the foundation was exposed to the ground, would have a layer of tar sprayed on it, that black gook they sprayed on, and that was called damp proofing. And what that did is it would resist water vapor movement It would also disengage the soil from the wall, because in the winter, when the soil freezes, it expands and contracts. And if it's attached to the wall, as it would expand and contract, it would lift the wall. And that would cause, and add freezing would structurally break apart a foundation wall. So it allowed the soil to move separately from the wall. But it was not waterproofing. So liquid water, even when it would get up against that damp proofing, all it would need is a little scratch, or, an area that didn't have the proper mill spray, and it would work its way through. And you would have tie holes from the foundation that it would get through. You would have typical settlement cracks in concrete, because folks, concrete does crack. Let's just be clear, it does. And the cracks would happen as it would settle, and water would get through, liquid water. We started to put the system platen, or the air gap drainage membrane, in to address the liquid water, and stop the hydrostatic pressure. We started to do that, I believe, in 2008, 2010. I'm going to say it was 2008, by building code. And that took care of a lot of the issues. So even now, if you have an older home or a home built before then, we always recommend that the first place to start with doing finished basements below grade is some outside work. Drain the water on the outside. Get system platen, air gap drainage membrane up against that wall, so that if liquid water does come in contact, let's say the grading can't drain the water fast enough and you get the 100-year storm, which apparently we've had 2 in the last 5 years, the water still won't be able to get through the wall because it neutralizes the pressure. So
the last question that another one just popped in. But was one person had said airtight, you mean above ground? So I think talking about and asking the question about airtightness above grade versus below grade.
Yeah, so it's going to be a little both, right? Because remember, the primary way that houses leak air in cold climates is by stack effect. The air inside the home is warmer than it is outside, because in Canada, there's only 2 seasons, this winter and last winter, right? So the warm air is always in that house, always wanting to push against the lid of the house. And the building science says when the air goes out the holes at the top of the structure, it pulls cold air in at the bottom of the structure. And in between is what's called a neutral pressure plane. And that's why all the holes in a house don't always leak equally. So when it comes to basements, they traditionally are cold if the house has a leaky air barrier on the top, because the air is going out the top and it's pulling the cold, wet, moist, soil gas ridden air into the basement. So again, start at the top, make a good air barrier, and have a good air barrier through the basement wall and through the slab as well. So stop the pressure that drives it in and close the holes that lets it in.
So we have a question on one of my favorite topics, which is renovation. Because if you want to learn building science and be challenged by it, apply it to old homes. So how would you address exterior insulation on a century home foundation with no footing?
Well, if you ask anybody that has tried this in the past, many of them, architects included, will tell you don't do anything. Because you're right, and Stephanie, you're exactly right. Those old rubble foundations have worked because they're kept warm. There's no insulation in the basement. The stone is kept warm, and they're dry because any water vapor moisture can just blow through, right? And as long as the stone is warm, it's going to be dry. And as long as that stone and rubble is warm, you're paying a huge penalty in energy. The basements aren't comfortable, and arguably the basements are humid and wet. So how do you fix it? Well, the one thing we've learned is you can't just go in and put insulation on the inside first, because if you do that, you make the stone cold. And if the stone gets cold, that ground outside is now going to grab a hold of the cold stone because the stone's cold. And when the ground does freeze and start to have ice lensing or heave because of frost, it's going to grab a hold of the stone and it's going to start to move that rubble foundation, and the foundation is going to start to fall apart. So what we've learned as Canadians, I love Canadian building science. Like, folks in Canada are so humble. They figured this out. They'll say it. Not other people, nobody else is really going to listen until it gets bad enough for long enough. But what Canadians figured out is, if you're going to do these rubble foundations right, go outside first and drain the water. Drain the water first and get a air gap drainage membrane, dimple board, or something on the outside that not only controls the hydrostatic pressure in the water, but it also separates the soil from the stone. So that if the stone is cold, the soil can still move, but there's a slip screen in between so it doesn't move the stone. So that's the first thing you would do. Ask any building science person, they'll tell you, drain the outside of an old rubble foundation first, take care of the liquid water management before you ever do anything on the inside. Second to that, then you can start to look at making that stone cold by putting insulation on the inside. You can start to, there's a lot of different ways to do that. That's a whole nother topic for another day. There are I've seen some scenarios, maybe Steph, you've seen this, where, inside, if you're not able to get to the outside of a foundation because of lot line tolerance issues, there are some scenarios where maybe you can dig out some drainage on the inside and do some underpinning. But again, that wall is still going to be susceptible to add freezing from the soil on the outside if you don't disengage it with system platen. I don't know. What's your experience been, Steph?
Yeah, I have seen that, and I've seen where people have spray foamed the inside of the rubble foundation, and it caused me a lot of angst for
Yeah.
all of the reasons that you have outlined. I know when I've worked, in renovation and worked on these sorts of things, especially with rubble foundation, if you're able to dig out around the outside, of course you have to. It can be really expensive because you have to do it in small sections, because otherwise you could get
Yeah.
collapse. But if you are able to, put the system platen on the outside, would you not then be able to add insulation on the outside at the same
You would.
time, right? And then
Exactly.
that way you can
Yep.
keep the wall warm, keep it dry, and then you've kind of resolved those issues on
Yeah.
the inside,
Yeah.
right?
That's right. If you can
But
do it
it's
all on the outside, that's awesome. That's
Exactly. And then they mentioned here about exterior insulation on the outside, and they indicated no footing as well. I mean, because you would want to get some weeping in and around the outside of that as
yeah,
well, while
that's
while
right.
you have it open. But just keeping in mind it's got to be
Yeah.
properly supported so it
The
doesn't collapse.
the other thing too with those rubble foundations is, and if there is no footing, the thing you have to be careful of is, you likely are, that footing, that bottom of that rubble foundation very well could still be above the frost line.
Mm.
So in those scenarios, and again, you're going to need some geotech direction on this, but what I've had to do in the past on a couple of historical homes I did one down in the Port Dover Jarvis area 15 years ago. And what we had to do with that rubble foundation is, I actually had to put insulation on the outside. And then I had to put a 4-foot wing of insulation in the ground out from the foundation. And what that did is, it created a heat bubble. So when the slab loses heat to the ground, it kept the bottom of that rubble foundation warm enough that there wasn't the formation of frost underneath it to push it up. So that can be done. Now, I'll give you a really good source for rubble foundations. RDH has a really good website with some case studies, RDH Building Science. The other one that I really like is, Joe Steebrook and team, Building Science Corporation. If you Google Building Science Corporation rubble foundation, you will find some really cool case studies and some details that are excellent. And some of those case studies were written by John Straub. I think Chris Schumacher might have been involved. Steve Brook was involved, and just some really neat case studies on how they did it. And again, some really simple detailing that sort of answers all this.
Mm-hmm. I had a comment here in the chat where somebody had mentioned regarding the stone foundations, and I guess the same applies to a triple brick foundation when it goes all the way
Yeah.
to the ground. Supporting masonry above, why not insulate below grade on the exterior and then just the top portion and rim joist on the interior so that there is a built-in thermal bridge between.
That's beautiful. If you can get to the outside, and again, that insulation on the outside, the thing you want to be really careful, not careful of, the primary thing, think about the building science reasons, the material you want to drain the rain, drain the water, break the hydrostatic pressure, and you warm the structure. If you can warm the structure likely will be dry, right? Warm and dry. So that's awesome. And then on the inside, absolutely. If you want to eliminate thermal bridging with inside outside, typically what you have to do, the rule of thumb is that the overlap of the inside and the outside to limit that little thermal bridge is about, just make sure the overlap is about 3 to 4 times the thickness of the rubble itself or of the foundation. And that will more or less take care of the thermal bridge through the structure.
3 to 4 times the thickness, because that rubble can be 18 inches.
That's right.
So that's you might as well just take it to the floor then.
You might as well, especially if it's just a crawl space. Yeah. But again, all this I will put in the caveat, have a good geotech person, but ask questions, because we've even had some geotech engineers. Sometimes, they get thinking about water, liquid water, and that's it. But remind them and ask for a little bit of help on, water vapor and some of these other things too, and they'll be able to do that.
The last question is, what are the pros and cons of spray foam?
So spray foam, you would have to talk to your spray foam manufacturers. We have seen studies, and there's been studies in Canada from, again, 30, 40 years ago, where closed cell spray foam was applied outside of the foundation, and it seems to work. But again, you need to talk to the manufacturers. On the inside of the wall, spray foam, again, does work. But again, it's the same principles. Don't just go into a home and, in the absence of doing things like drainage on the outside, disengaging the soil from the foundation, all those things, don't just think that spray foaming the inside of that foundation, rubble or new, is going to take care of your problems. You need to look at it holistically. Now, in a new home setting, spray foam on the inside, or in an existing home where there's already drainage and it's in good shape, spray foam on the inside, perfect. It's just like a low permeance rigid board stock foam. The thing we would encourage is that you use a low perm closed cell spray foam. You're going to hear terms like open cell, closed cell, half pound, 2 pound. What you want is a closed cell in most cases in that area. And what that is that foam then can resist that inward vapor drive. And it also is an air barrier. And then again, just remember, spray foams, like board stock foams, will have to be protected with a Class B thermal barrier somewhere in the house. Again, that can be the drywall finish, or if you're not finishing it before closing, you'll probably need something like a rock wool or a thermofiber there.
Another question just came into the chat, and they asked if there's a flood, how do you keep the basement walls dry for capillary moisture effects?
Good luck. So number one, design the home with the hope that you can drain the water quickly. If there's a flood, it's not going to be the capillary that you're going to be worried about. Because once water is inside the home, the first thing you're going to be worried about is getting the structure and the materials dry. That's a whole nother topic for another day. If you do live in a flood prone area, not necessarily high water table, poor drainage, humid, whatever else, but if you do run the risk of flood prone below grade, that is an entirely different topic. And that's another topic for another day, right? That is, you want backflow protectors, number one, on your drains. Huge deal. You may want to consider other mitigation measures. You will want to be very careful about what you select for insulation materials as well. Some areas of the country that are flood protected will actually mandate different materials inside the wall. They may keep the insulation up 4 to 5 inches at the base of the wall in some cases. So that's a whole nother subject. Some flood prone protected areas require, believe it or not, pressure treated wood to be used inside the home in some of those scenarios. So the one thing I will say about that, not many people know this, the Greener Homes program that's available for energy efficiency upgrades also has money available for resilience protection features. So that $5,000 can also be made available for doing things like flood protection, backflow protection. If you need more information on that, get a hold of us and we can connect you with the teams that do that.
We had one other question that came in. In the segment on the of the wall, you do not show the air barrier connection. Is sealing the top of the rigid on the inside still required? And also, why is poly recommended under the slab if you're using rigid under the slab?
Yeah, so what we do show, and my apology, because that was a really good question that was asked a bit ago. And again, I should try to get a details a little bigger. If you actually look here, you'll see a little tiny, just a very, very small, let me see if I can blow this up. You'll actually see a very small bead of acoustical sealant that's been placed here at the top. And that is, remember, to seal between that rigid board stock and the wall. You definitely need to seal that per your point, absolutely, with rigid board stock. If it's spray applied, that's not needful, okay? The other thing too is poly underneath the slab. Depending on where you are, so a couple of things. Most of the time that poly is required under the slab has to do with the building code requirement that there be a continuous air barrier from the slab up to the wall. Now, the building code in Ontario gives that ability through either sealing the concrete, the cracks with caulking, or depends on your building officials, again, and what their preference is, to having poly or something under the slab that makes a continuous air barrier. So that's one reason why poly might be used. The other reason why poly might be used is if you are having to mitigate against soil gas, you will need, again, a good air barrier under there. In some cases, there are some areas of Ontario and other areas in Canada where poly is not going to be good enough for a soil gas barrier. It'll be good enough for an air barrier, but not good enough for a radon barrier. And in those cases, you're going to have to bump up your under slab material to, radon block, a very heavy material that is, certified as a radon block. I will tell you that there are some insulation board manufacturers, for instance, Owens Corning, their pink board. Some spray foam manufacturers now have their certification as a radon barrier below the slab. But again, you need to talk to the manufacturers about that. Outside of that, the poly is, again, it does provide some protection from, let's say, water vapor diffusion that might come from moist soils that would sit down under the clean stone. Hopefully that's helpful.
We got lots of great questions. On the topic of thermal barriers, could you use a Class A foam and not have to cover it with a thermal barrier like drywall?
I don't know. So I'm not sure what a Class A foam is. In this slide, what this is referencing is a Class B thermal barrier. So there are various classes of thermal barriers, not foams, but Class B thermal barriers. So for instance, a Class B thermal barrier would be something that is a material that is resistant to a certain amount of flame spread and to some smoke development. So that would be drywall. I think even plywood would fit that. I think it might fit that. Mineral wool insulation like rock wool or thermofiber. But again, I'm not familiar with a Class A insulation, but you might be. If there is, put it in the chat. So.
One comment or question that came in was regarding radon. So because radon is heavier than air,
Mhm.
what do you suggest as the best route for venting below the slab?
Um, so I'm not going to consider myself to be a radon expert. Stephanie actually has her radon remediation and mitigator training. I'll just comment that one of the things we recommend as best practice is in keeping with the National Building Code of Canada. Now, Ontario has not adopted this portion of the National Building Code. Most of the other provinces have. But in the National Building Code of Canada, it speaks to the requirement for what is called a sub-slab depressurization rough-in. So during construction, you have your clean stone. We should put a detail in here. Sorry about that. We weren't really focusing on radon, but you have your clean stone. You have a perforated pipe that is in that stone, and you have it stubbed up through the concrete with it capped and marked for future use in case the levels of radon do increase in the home after it's occupied. Now, in addition to that, get a really good air barrier in there as well too through one of these measures we've talked about. Make sure the house is airtight. Make sure you have a active mechanical ventilation device that is balanced. And what I mean by that is don't just rely on bathroom fans for your ventilation. Get an HRV or an ERV. And why do we say that? Well, if all you're relying on is a bathroom fan to bring fresh air into your home, you're going to go turn that bathroom fan on somewhere upstairs. It's going to suck air out. And where in the world is it going to get the air from that comes in? It's going to get it from the basement. It's going to get it from your poor air barrier. It's going to bring in the radon gas. So what an ERV or an HRV does is it has two fans. It pushes air out and it pulls air in through controlled holes above grade. So it doesn't imbalance the pressures in the home. That's what we would suggest to start out with. And then from there, follow the Health Canada guidelines on, what type of fans, follow the direction of a certified radon remediation, CARS, the Canadian Association of Radon Technicians, their direction on the sizing of the fan for the under slab. Those will be the folks that will really lead you through how to do the complete radon system.
Yeah, it's quite involved. I had taken that and that program and did my project for it, and it's what builders in our areas are doing is, like you said, a perforated pipe and a big loop below the slab with a sock on it with the stub up, and then if they're in a radon gas barrier under the slab, and then if radon levels are high, then it's a easier install where you have the properly sized fan and it just goes out through the rim. But it is a rather complicated calculation that involves using a micromanometer to measure the pressure and drag essentially across the slab, under the slab, as well as the length of the pipe. And in order to have a properly sized fan, because you don't want one that's too powerful or too noisy, and all the rest of it. So that's
Nice.
where Karst and the radon teams can help provide
Good.
direction on that.
Good.
So, well, we're at
I
2:32.
I did see one note. Sorry, Lance. I just want to note in chat, Lance, thank you for that. So Lance did confirm Class A foam. So I had never heard Class A associated with the foam type, but it sounds like there's only a Class A thermal barrier needed for polyiso, or foams that, let's say, Lance has written here, that have a flame spread less than or equal to 25, smoke development equal or less than 450. In that case, you wouldn't need something as robust as drywall, something as robust as mineral wool. That's phenomenal information, Lance. So there you go. If you are using a type of foam that is not like XPS or something like that, then you won't need that. Now, the only thing I'll remind you of is that There are some of those foams, EPS or others, that may not require a Class B thermal barrier. However, their properties are different as well too. Some of them may have very high permeability ratings. Some of those foams may have high water absorption properties. So again, that leads us down another path to be a little bit careful of, but thanks for that, Lance. So, good.
Well, we are out of time now.
Excellent.
Okay.
Well, thank you, folks. Those are
Yes.
awesome questions. One of
Yes,
these days
thank
we
you.
can do this in person. That would be good.
Yes, eventually. But thank goodness for Zoom. So thank you, everybody. Our next session is in September, and it'll be Gord and myself, and we're talking about indoor air quality. So look for that on our website. There will be a link in the resource email that I'll send out hopefully by tomorrow. And so I hope you all have a great afternoon, and thank you so much for joining us. Thanks, Andy. And of course, thank you to Enbridge for their sponsorship.
Absolutely. Thank you, Susan and team at Enbridge. I still find it amazing that that team, what they have done for the residential construction community in Ontario is phenomenal. I mean, we can credit them, their support of programs, efficiency, building science. We can credit them with some pretty cool advances in the building science space. So thanks to Enbridge.
Absolutely. When I close the session, a little Survey Monkey link will come up. Please give us your feedback. We'd love to hear from you. Okay.
Awesome.
Thank you. And
Thank you,
bye,
folks.
everybody.
Take care.